So my name is Guilherme Vaz. I'm Portuguese, half Dutch, and we come from all the way from Portugal, and talking about going towards the first underwater acoustics of digital twin. So it's a buzzword a lot of people use in Europe, a representation of the world. And but we can also do things. It's not only to see, but you can also interact. So our focus here it's acoustics, and we come from blueOASIS. This was a startup 3 years ago. We were 4, now we are 20, and we made this spin-off called HydroTwin, and we're going to talk only about HydroTwin. So first, a quiz. Which one is Lisbon and which one is San Francisco? Because it's very similar. San Francisco and Lisbon are like twin cities, not formal, but very similar in a lot of aspects. Not only the bridge, but the water, the vibe, the food. So it's, I mean, you may notice, but Lisbon is in the top and San Francisco is on the bottom. Okay, so the bridge in Portugal, it's a copy of the bridge of San Francisco. It was the same company that did the bridge in San Francisco did in Lisbon. So we're going to speak about acoustics. And acoustics, like I say, we have 2 types of acoustics. We have noise and sound. So normally noise is something we don't like and sound is something we like. And so for the pitch of the digital twin, we always say that, oh, can you take my picture from there? So we have noise and we come from the offshore world. So a lot of, in Europe, offshore wind is very strong. And so a lot of these structures make a lot of noise. And we were like 10 years ago measuring all the noise with these, what I call trivial or old fashioned hydrophones, putting in the water, go by boat, leave it there 3 months, picking it up, bring it to shore, and then, oops, nothing is there, or doing it again. So it was very expensive. It's not from this time. And most of biologists or acousticians were doing that. And some guys like me and Tiago, we are both aerospace engineers. So we come from the space and we said, this cannot be. So 3 years ago, we started to see, before we knew so far, before we knew iOS, it's kind of different continent even, we started to see if we could automatize and make it a little bit modern and less manual labor. So one thing was for environmental impact. We need to, once something goes into the water in Europe, you need to measure the noise that is the background noise, then the noise that is doing installation and noise doing the operation. So we have 20 years of a project that you can measure noise. So that's one of the targets. The other objective we had is, like somebody said, and maybe it was Chris, I don't know, to hear is to see underwater. There's no other way. So a lot of people, including us, we're doing fancy stuff with cameras and AI. Nice. In Hawaii or in Caribbean, try to do it here. For instance, with this water or in a river, you see maybe 1 meter in front of you. So the only way of to see is to hear. And how can we see and track acoustic sources? Can we do a Google Maps of the bottom of the ocean in terms of acoustic sources? Can we track whales and dolphins, but also all kinds of stuff? That was our objective. And so the solution to tackle both the noise and the sound, noise, how can we monitor in order to mitigate it, and sound in order to see, was to find a solution that we call HydroTwin, twin from digital twin. It's an AI-based system. It's a platform that permits to monitor the underwater soundscape. Was using already Industry 4.0. So when he started, even before so far, this is a new drawing. We were using already LoRa 1 4 years ago. We are already using a lot of edge computing also. And our idea is to measure the acoustics, to do the detection and classification, to do noise maps. I will show what is that, and to send it all to shore real time. And our system HydroTwin, it's hardware agnostics and platform agnostics. So now we have a so far buoy, but we have also, as you will see afterwards, a cable version, or working in a version to put in a glider, or in an underwater vessel, or in a ship. That's also Nice to have. So this is what we had. So this is HydroTwin. So, and this is the cable version. So not the version with spotter, but using bristle mouth. Um, and um, and this was the version that we were doing before we knew any of you. Okay. So these are now our current products that we already have tested, and I will show you something working in real time. So we have the Scout, Scout for sound classification and observation underwater, and we have the Scout S, S from spotter, and we have the Scout C, C from cable. And driving all this stuff, we have the HydroTwin software. So the software does AI, so the classification of five sources, but also permits to visualize everything real time, but permits also, or will permit soon, people to get their own data, a WAV file, you put it there, and or we classify it and you say what is the classes, or if you see that there are classes that we see there is something strange, but we don't know what is the class, you can label it, you push the button, you send it, and you get an AI model. So it permits also people that do not want to do AI or do not have the HPC resources to send their own data. So these are the three things that we have on the pipeline. Scout S still with the dev kit here, but we'll talk about that later. And this Scout S is TRL9 because we have tested and we'll see in the Azores in a very harsh environment. But to do a digital twin, you don't need only sensors. You need also a model, because what you want is to do fast things, and you have a model, you have the sensors, because the sensors is any spotter or any sensor, it's a point, okay? It's a point in, even if you have 1 million sensors, it's 1 million points, okay? So what we built also was a tool, it's called Raindrop. Now it's here the logo. That permits to do noise maps, which is depending on the bathymetry, depending on the water salinity, density, properties, acoustic impedance of the very properties, and all the noise sources, we can do and map all the noise at the particular location. See if I can make it work. No, thanks. Oh yeah, it's the mouse there, right? So what you see is a portion of like 100 by 100 kilometers of all the ships being, all the ships that have IIS. So we, based on naval architecture, we can pass the ship speed, draft, weight to a monopole source, acoustic source. And based on high performance computing, we do a lot of calculations beforehand. And we can do this on real time afterwards with all the sources that we have. So what you see is during a military exercise, you see the ferry there in the river, you see a lot of ships with the names, you see a big canyon where the noise is not propagating in the same way. This is a 3D, this is just a cut. And you see there 5 spotters. In fact, it's 5 HydroTwins that we want to couple with this, because there's not all ships have IAS, and whales and dolphins, so far as I know, do not have IAS. So we want to combine both the spatial resolution of a model with the temporal resolution of HydroTwin in order to, in this map, to put where are the whales, where are the dolphins, and where are the things that do not have AIS. And which kind of applications these have, you can imagine. First, with fish and mammals conservation, we have an office in Azores, so this is very critical. We have 30% of the water of Azores is now marine protected area, one of the biggest sanctuaries now in the world. Environmental impact for offshore, sustainable tourism, whale watching, but also in the lower parts, things that maybe we don't want to have, but we need to have, especially in Europe nowadays. Critical infrastructure, safety. Maybe you heard about Nord Stream in Northern Europe, illegal fishing. Those fishermen, they switch off the AIS every time they're doing something naughty. So, and defense, as you can imagine. In fact, my face is, yeah. So data is the core for any AI. And so we had to gather a lot of data. So we were helped by the Portuguese Navy and by NATO navies, in fact, on all these 4 exercises that open for everybody from NATO. It's an autonomous and robotic exercise called REPMUS, where we got a lot of data to see if the the dolphin community is being affected during the exercise. So we got a lot of military and civil data. Sorry, and civil data that we need to process. So data is the core. We also have from the Azores more than 4 years of continuous sound data, all kinds of classes for whales and dolphins. And in AI, one thing that we have to be careful is the bias. So we don't have data from all these classes in the same way. So we have to be very careful. So sometimes, and what we have now in the version 1.0, we have all these classes aggregated in one big class, call it dolphin, call it whale, and then we have a good model. So once we have a lot of data from all these different classes, you can go deeper and you can get accurate results. We also put it for the community. We live close to the coast, where there's a big surfing community. And so a lot of people want to help us to label the data. We have a bunch. In fact, I don't know what's the gender problem, because we have a bunch of 20 ladies helping us in the office, listening to all these files of vessels or of whales and labeling spectrograms in order for us to improve the AI. So when we start to play this with AI, you could pick up some AI out of the shelf. YOLO is one of them. And we say, okay, done. We do YOLO. We put this in our hardware. We put it in water and it's working. Well, YOLO was not done to do a digital twin, was not done to be underwater. So it needs a lot of power. So it doesn't work in a small device under spotter. So we had to find our own AI in order to have maybe a little bit less accuracy, but can run on edge computing. And that's why we have in-house ensemble CNNs. It's called an ensemble CNN. For each class, we have an CNN. And then with the meta learner, we combine all the CNNs for all these 5 classes. So sometimes it's easy to pick up something out of the shelf, like AI now in the computer works well, but we are here to put stuff in water. It's not to work only in the computer. So what you see here, for instance, you hear a dolphin. You see the system here lower detecting that it's a vessel and a dolphin. On the right-hand side is the YOLO. Now we're passing to our own. That detects the whale. But now imagine these 3 sounds at the same time, and you have to capture that. This is not training AI from aquarium. It's training AI for things in the water. So the overlapping of the sound, masking, quite complicated. Even more chaotic in real life, okay? So then it comes, we needed some hardware. We made our hardware when we didn't know even that America existed. So, yeah, we are Europeans. So, but we knew about Spotter because somebody told us that there was a Dutch-American guy, I'm also Dutch, that said there's some nice guy that has a buoy. So we speed up a lot our development by going with Spotter. We were developing our own buoy and we abandoned because we thought that Spotter was the way to go and it was much faster for our own developments. The same now with the hardware. We develop our own Pi, we develop our own system, and we think that the way to go is to partner with Borealis, and we're going to abandon our hardware. So we're going to partner with SOFAR and Borealis, and we will keep our test facilities, our humongous amount of data, and AI knowledge and software. So, Tiago, do you want to show the dashboard working? So this is an announcement. We will partner with Borealis, OS, and so I think we'll make a triangle of Spotter, Hydra Twin, and Borealis, and Tiago will show the dashboard working with data coming real time from Azores.
Yeah, hopefully. Let me just switch switch screens because Tiago, thanks Guilherme for the presentation of Hydro's doing until now. I will just give a brief overview of something that we have been recently working on, and we are starting to put this out in the public. So this is the dashboard where we collect all of the data and present it to the user. Because yeah, we might have a lot of sensors offshore with AI running there, but it needs to be presented to the user in a meaningful way. And this is the web app that we have been working on. So the user is able to see per buoy the detections immediately in this case, 60 minutes. So you can see here the three labels that we were monitoring in terms of dolphins, whales, and vessels, and immediately can get an overview also of the noise levels in the region. If you scroll down a little bit, yeah, we have more information about the spotter that it's powering and providing communications to the Scout S in this case. This buoy, as Guilherme mentioned, it's live from Azores. We actually had to remove it to do some maintenance, and for now it's sitting in the marina, but soon we will put it back in the original place where it was moored because of the weather, as you can see here. And if we scroll down out, you can see where it is located in the central part of the archipelago. Here we have some spotter data also in terms of wave, wind, pressure, but of course, if there's more sensors, we can also incorporate that into this dashboard. And of course, if we continue to scroll down, we have the information really about the AI models that are running in terms of detections. We can also have some information about the sound pressure levels. In this case, let me see if I can see. You can see the sound levels for the different third octave level bands. Spectrograms, anomaly summaries, etc. And in relation also with something that Guilherme mentioned during his slides, there's also a new feature that we are still working on, but that I will already show you an example of it. Collect kind of acoustic databases that might come not only from the buoys that we have, but also from maybe past data sets, where the user can really run those AI models, get a sense of what is happening in each file, interact with them, listen to them, and if necessary, relabel them to generate new AI models. So returning now back to the presentation, which is almost finished. We have been already, of course, in some places doing the tests of our system, of our software. One of them was really in REPMUS of 2024, as you can see here in Sesimbra. On the right side, you can also see our tank testing that we had back in November at Marin in the Netherlands. We were looking at how the different wave and current conditions impacted the self-noise of the hardware and the effectiveness of the AI models. And of course, we also took some of the time to test some configurations of the moorings with the spotter.
We compared the wave measurements from spotter with the wave measurements for the basin. They were quite okay.
That's good news. And yeah, this year, 2025, we have a lot more new locations, exciting places to be. But of course, Fayal Island in Azores continues to be our main test bed. And this is a quick video that we prepared showing some of the places there. So Azores is really in the middle of the North Atlantic. This is the spotter with Scout S that we have deployed since May. It's there, and in this case, it was detecting the fishing vessel that was passing by in the channel there and sending that data real time to the dashboard. Here is another overview of spotter, and then we have here one of the maintenance operations that we did with a diver. Although we also have been working on the moorings, and right now we no longer need these divers to help us to access the Scout. We can do it ourselves directly.
Yeah, so the moorings of when we start with spotter, they are quite nice, but not for big depth and for other locations. So we had to redesign, using still some spotter material, we had to redesign the moorings. We can go to depths here, it's 100 meters, we can go until 1,000. So you have to redesign the moorings. You cannot just buy the moorings from spotters just out of the shelf. So we have to redesign the moorings for that.
I think we're out of time here. But
yeah.
Any closing thoughts?
Yeah, the next steps. So Twin technology can be applied. So we are going to integrate with Borealis. We're developing also for a glider, working on a militarization. We hope that we have some help also from some people from here to work on the militarization. First thing is that the buoy has to be not in yellow. Focus on the sales, and also to please you a little bit, we have big projects in Azores. If we get it funded, we're going to deploy 150 scouts, so 150 sensors of acoustics, not only 150 spotters. In terms of needs, I leave this to Tiago for tomorrow. We are very pushy and we need more power. Okay, thank you.